Hello. In this video, let's pretend that we have to solve a system of linear equations. And the first equation is 2x plus y is 3. The second one is 4x plus 2y is 8. So we have two methods for solving a system of linear equations like this. The two lines look for finding out where they cross. And the two methods are substitution and elimination. Now both will give us the same result. So let us try substitution first. Now to do substitution, we just need to solve one of the equations for either x or y. Let's solve the first. It has smaller numbers, so let's solve it for the y, because the number in front of y is 1, so we wouldn't have to do any division to get y by itself. So to get y by itself, we have 2x plus y is 3, so minus into x from both sides, we get 3 minus 2x. So this is what y equals, and if that's what y equals, we can use it in our second equation in place of y. So let's do that. That makes 4x plus 2 times y, which is now going to be 3 minus 2x, and the rest of the question is the same, equals 8. So now we follow the order of operations, we follow PEMDAS, and we simplify everything that we see. So multiplying through, we have 2 times 3 is 6, 2 times negative 2 is negative 4x is 8. Now at this point we see something cancels off. 4x minus 4x actually happens to be nothing, which leaves us with 6 equals 8. Well, there is no x to make it true, and 6 is never 8. Not true. Never true. Now, when that happens, we know that there is no solution. So our system has no solution. We can write it no solution, we can put a 0 with a line through it, means does not exist or there is nothing. And that happens when the two lines are parallel. Now let us use, so this is it, this is the end of how to solve a system of equations if it has no solution. So substitution method, we're done. If we happen to like elimination, just for practice, let us do that and see how that plays out. So here for elimination, let's add the two equations in such a way that one of the letters cancels off. And so here, let's say we wanted to cancel x. To do this, we have sorry about that, little squiggly. So to do this, we see that the numbers in front of x are 2 and 4, and the smallest common denominator between 2 and 4 would be 4. So if we simply multiply the first number by negative 2 all the way across, minus 2, that would make it negative 4x, negative 2 times y is negative 2y, and on the other side as well, negative 2 times 3 is negative 6. The second equation is unchanged, we copy it over, and now we are ready to use addition or elimination. So if we add the two equations, we see something happens. 4x and minus 4x cancels off, minus 2y plus 2y cancels off, which makes 0. On the other side, negative 6 plus 8 is 2. Well, once again, there is no x or y to make it true, and 0 is never true. So never. And at this point we come to the same conclusions. The lines must be parallel, and we have no solution. Now, if we wish to visually check to see if the two lines are parallel, we would need the calculator. And to use the calculator, we need to solve each one of our equations for the y. So here, if we wish to use the calculator, we start back with our equations. 2x plus y is 3. Solving it for the y, we minus 2x from both sides, making 3 minus 2x as before. Now the second equation is 4x plus 2y is 8. To get y by itself, we can minus 4x from both sides of equation, and that makes 2y equals 8 minus 4x. Dividing everything through by 2, we'll get y by itself. So now, if we take these two equations and type them in our calculator, we should see two lines that are parallel. Let's have a look. So here is our calculator, and y equals, first equation is 3 minus 2x, second equation is 8 minus 4x divided by 2. And let's look at a picture. First equation, second equation, they look parallel. They are really close next to each other, but they do appear to be parallel. So that confirms that if we're looking for the place where these two lines cross, that would not be possible. So our answer, no solution, actually makes sense visually. And that's it for this video. Thanks a lot.